We're going to continue working with square roots today. I'm in lesson 5.9 on page 431. And the name of this section is called Adding and Subtracting Square Roots. Now, we've already done some dealing with square roots in the past. We've learned how to simplify them or break them down into their simpler terms. And we've already done some division, some multiplication, and a little bit of addition and subtraction. But we're going to go to adding and subtracting roots when you cannot take the square root of a number. For example, we did some earlier that were like this, square root of 9 plus the square root of 16. And when you simplify both of these, the square root of 9 was 3, the square root of 16 was 4. We add those together and we get 7. Well, in this section we're going to run into square roots that you can't reduce to the point where you get rid of the root. So we may have something like the square root of 6 plus the square root of 8. Well, you can't take the square root of either one of those, so what do you do with those? So that's what we're going to look at today in this particular section. But let's start out with using the distributive property to combine terms with radicals in them. So we're going to do a subtraction sign. If you remember a couple lessons ago, I had said that if you have numbers in your radical sign that are similar, you can combine those. If they're different, you cannot combine those. So, going to go a little bit different than what the book says as far as bringing these two terms together. And that being a little bit different means that what we're going to do is I'm going to, right or wrong, it does seem to work and make sense, treat this kind of like the same way that we would treat a variable. If the variables are different, you can't add or subtract. I can't add 5x plus 3y because my variables are different. If my variables were the same and this were an x, I could combine those. And what do I do when I combine those? I take 5 plus the 3 and get 8, and I just drag the x. It's kind of like 5 quarters plus 3 quarters equals 8 quarters. It's the same way when it comes to radicals. Because I have a square root of 6 in both of the terms that I have up here, I can combine these. So all I'm going to do is add or subtract the numbers outside the radical sign and just drag the radical with me. So my answer ends up being 2 square root of 6. And that'll happen the same way with addition or subtraction. So even when I get things like 6 square root of x plus 3 square root of x. Well, I've got 6 of the square roots of x, 3 of the square roots of x. I just add those together and I get 9 square root of x, and I'm done. And it doesn't matter how long of a string of numbers I have here. You just add up the numbers outside of the radical sign and drag the radical sign along with you, and you're okay. But sometimes we run into some radicals that are not similar. So we run into something along this line, square root of 12 plus the square root of 75. Now when you run into things like this, your first step is to try to figure out if it's possible to get the number under the radical sign to be the same. So if I can simplify this and simplify this and get the number and the radical sign to be the same, then I can combine those. So if you remember, what we did for simplification is we did the prime factors. So we get the square root of 2 times 2 times 3. Okay? And then what we did is we took the couples and brought them out and left the single guy all by himself. So we get 2 square root of 3. Do the same thing with the 75. We get a 3, 25, 5, 5. We get the square root of 5 times 5 times 3. Bring that couple out. And lo and behold, we get a radical sign that's the same. So we can combine these two and get 7 square root of 3. So if we were to take square root of 12 plus the square root of 75, we get 7 times the square root of 3. So that's how you do those there. If the radical sign is not the same, combining what you need in order to make it the same or simplify it so that you can do that. Okay. Let's look at another one here. Let's look at the square root of 18 plus the square root of 50 plus, let's do minus the square root of 8. And this is the example number 4 on page 432. Alright, so we're going to reduce all these or simplify all these. And this simplifies to 3 square root of 2. This simplifies, well, I don't know that one just in my head, so, okay, that one will simplify to 5 square root of 2. And this simplifies to 2 square root of 2. That being the case, we have square roots of 2 all along here, so we can go 3 plus 5 is 8, minus 2 is 6. And we're good with that. Brings us to our next example. Example 5. Example 5 says 5 square root of 54 minus 3 square root of 24. Alright, so square root of 54. That's what we've got here. 2 and 27. 3, 9, 3, 3. So that gives me a pair here that I'm going to pull out. So when I pull that pair out, I'm pulling that 3 out, and it's going to combine with the 5. So and it ends up being a multiplication times the 5, not addition to the 5. So we're going to pull that out, and we're left with a 3 and a 2 in there, which is 6. And then our minus 3. Our 24 changes to 2, 12, 2, 6, 2, 3. So I've got a couple right here. So I'm going to bring that couple out and leave my 6 in there like that. So now I've got 15 square root of 6 minus 6 square root of 6 gives me 9 square root of 6, and I'm done. So take simplify these. If you've got similar numbers inside the radical sign, then you can combine. If you don't get similar numbers in there, then you can't go any further. You just stop right where you are and don't assume that you're missing out on something, because they're not always supposed to work out. It's just kind of like life. Alright, so 5 square root of 12 x cubed. And then what we're going to, this radical sign goes all the way across, minus 3 square root of 75 x cubed. Alright, so let's factor out what we can. We have 2 times 2 times 3 times x times x times x here, and a 5. We can pull out this and this, so we end up with 5 times 2 times x square root of what we have left, 3x. And over here we have 75 reduces to 3, 25, 5, 5. So what we have left here is 3. Take my pair here, and I've got 3 x's here. So I'll pull out 1x, and I'm left with 3x in there. So I've got 10x, 3x minus 15x square root of 3x. Subtract those, and I'm done with that. Alright, let's do some examples on page 433, problem set 5.9 in our next lesson. But notice how we took 10x minus 15x and got negative 5x. So don't forget to be looking at that.